Hello and welcome. My name is Doug Munhut, and I'm an application specialist at Design Fusion. In this video, I'll be sharing some information on Siemens Tecnomatix Process Simulate. Process Simulate is a tool for planning, simulating, and validating robotic operations, human tasks, and automation during the entire product development lifecycle. Let's go ahead and look at some of Process Simulate's unique robotic simulation features. When selecting a robot for a project, you have a lot of options. To make your choice easier, you can use the Process Simulate Robot Library. This is a collection of robot models from leading vendors that can be easily downloaded into your simulation. You can filter the available robots by brand, payload capacity, and reach. There are also other assets available for download, such as conveyors. The content of the library is continually growing, and new additions or changes are immediately available to all users. This demonstrates one of the major benefits of Process Simulate. It is brand agnostic. What this means is that any major brand of robot is compatible, as opposed to traditional vendor tools that only work with their own brand. With Process Simulate, you can mix brands on the same project and have them work together seamlessly. With Process Simulate, one can validate an entire robotic cell. The robot, which is the central element of the cell, is provided as an out-of-the-box component and has a built-in kinematic structure. Process Simulate also supports modeling of complex kinematic devices, enabling the user to define joints, links, poses, and more. To achieve the most accurate digital twin of a robotic cell, all kinematic components can be simulated and verified statically or during a simulation run. By using Process Simulate analysis tools, the user can test and verify the robotic assembly process with regards to the geometric and kinematic constraints. In this example, it is desired to set the battery pack on the conveyor. Then, once both robots can reach all process locations, a sensor is created to detect the battery pack is in the right place. The system allows one to create proximity and light sensors to define the behavior, reflecting the behavior of parallel sensors existing on the shop floor. Such sensors are used to detect a part presence or absence, or to emulate the behavior of safety screens. The ability to leverage 3D data of products and resources facilitates virtual validation, as well as optimization and commissioning of complex manufacturing processes, which results in faster launch and higher production quality. Process Simulate is a useful tool for creating robotic paths. During the path creation phase, collision detection is crucial. Process Simulate helps you dynamically detect collisions through robot simulation, improving worker safety and preventing costly damage to equipment. Using the collision detection mechanism, you can carefully analyze whether there is a penetration, contact collision, or near-miss violation. Process Simulate's intuitive user interface makes adding a robotic location or modifying an existing one an easy task. You can simply copy, paste locations, drag and drop, change the order of positions, rename the locations, and more. Then, to verify the updates and changes, you can simulate the entire process sequence, a single path, or even a selected segment, making for an efficient validation process. You can specify the robotic motion type and speed using the path editor. Here, the motion type was changed from point-to-point movement to linear movement, and the speed was also specified. For robot path planning, Process Simulate also includes the Automatic Path Planner tool. Once you have the desired points you want the robot to reach, the APP uses machine learning to plan paths and operation sequences such that all collisions are avoided and cycle times are optimized. This allows you to refine the path planning of your robot with very little effort, while also making sure you have a safe workspace. You could see it at work here in this clip, where initially there are collisions between the robots, and after using the APP, the process is altered such that the robots work together without any interference. By simulating the operation, we can understand the interaction between robots, tools, and parts, which can be difficult in a physical setup. Simulations give us detailed data which can be used in identifying and implementing process improvements. By visualizing the robot's movements in this virtual environment, potential collisions or reachability issues are immediately apparent. Doing this before any physical implementation helps to reduce costs and save time. Process Simulate is capable of simulating a wide variety of robotic operations. Here we can see the development of a streamlined spot welding process. Robotic spot welding provides both high repeatability and consistent weld quality, but can lack adaptability when compared to manual welding. With the addition of Process Simulate, you can edit and test the weld operations before moving to the shop floor. Changes to robot paths can be made on the fly, giving robots the benefit of repeatability as well as flexibility. For riveting operations, robots are great because they are fast and accurate in terms of the force used for each rivet, leading to less rework and scrap. Process Simulate allows the robot's movements to be visualized so that the precise placement of each rivet can be verified, and any issues will be caught ahead of real-world implementation. Process Simulate can also handle continuous path processes, such as arc welding. Process Simulate is able to create weld paths, generate optimal workpiece orientations, and then export these directly to the workshop floor. Other robotic operations that can be simulated with Process Simulate include pick-and-place operations, cutting, drilling, deburring, sealing, gluing, polishing, and painting.